tuning of radio receiver. The tuning circuit of radio or TV is based on LCR resonant circuit. And if you remember, resonant frequency F is given by 1 upon 2 pi LC. Signals of different frequencies are transmitted from different stations and they are received by the antenna. Here antenna is shown, this is inductor. And corresponding to these frequencies, a number of voltages appear across the series LCR circuit. This is shown. So here this is L, this is C, and there is resistance in the circuit. So a number of voltages appear across the series LCR circuit. Maximum current flows for that AC voltage which has frequency equal to resonant frequency. If Q value of the circuit is large, the signals will be very big. By changing the value of adjustable capacitor, see here this arrow shows that this capacitor can be adjusted to certain value so that resonant condition can be created. And when this situation is met, then by changing the value of the adjustable capacitor C, the signals from the desired station can be tuned in. Now, let's see some numericals. In a series LCR circuit, the resonant frequency is 800 Hz. The half power points are obtained at frequencies 745 Hz and 855 Hz. Find Q factor and bandwidth. If you remember, this is graph. So this value corresponds to resonant frequency, and at this point, the value of current is I0, and then there are 2 points here where value of current reduces to root 2 times I0 divided by root 2. So corresponding to this value frequency is omega 1, and corresponding to this value frequency is omega 2. So here this distance is called bandwidth. Here this is given in terms of F. So in a series LCR circuit, the resonant frequency is 800 Hz. The half power points are obtained at frequencies 745 Hz and 855 Hz. So these corresponding to these values, F1 and F2 are given. Find Q factor and bandwidth. So let's find out Q factor. So Q factor, Q is equal to, in terms of frequency, Fr divided by F2 minus F1. This can be also written as Q equal to omega R divided by omega 2 minus omega 1. So that will involve 2 pi and 2 pi will get cancelled. That's why it can be written Q equal to Fr divided by F2 minus F1. We can put the values. Fr is given as 800. So 800 divided by 855 minus 745. So this will be equal to 800 divided by 110, which is equal to 7.27. So quality factor is 7.27 and bandwidth equal to F2 minus F1. So it will be 855 minus 745. So that will be 110. Now let's see next question. An inductor of 200 millihenry, capacitor of 400 microfarad, and a resistance of 10 ohm are connected in series to an AC source of 50 volt of variable frequency. Variable frequency. Find the Q factor of the circuit. Okay, so if you remember, Q factor is defined as 1 upon R times root of L upon C. So we put values. Resistance is 10 ohm, so 1 upon 10 times root of L. L is 200 millihenry, 10 power minus 3, divided by C is 400 picofarad. So, sorry, 400 microfarad, 400 into 10 power minus 6. So let's simplify it. 1 upon 10 times root of, here 0 will cancel out, 1 upon 2 times, this will become 10 power 3. It means 1000 divided by 2, that is 500. 1 upon 10, 500. So this can be written as 10 upon 10 times root 5. So 10 will cancel out and root 5 will be left, which is our answer. Thank you for watching.